Hello everybody. So we are in the third class of the basic concepts of chemistry. Now in the last class we had started with the different laws that is required for the study of chemistry, right? The first law we studied is the law of conservation of mass. Hope you understood that. We had done a numerical. I am going to give you some homeworks also today related to the laws. The second law we are going to study is the law of definite proportion or constant proportion. The law of definite or constant proportion. Constant proportion. Simple. Any compound, it can be produced, obviously compounds are produced chemically, it can be produced from any chemical reaction, for a number of chemical reactions. But according to this law, that doesn't matter that from where and how the compound is produced. Whichever way the compound is produced, the elements that is present in them or in it in a different manner will find a simple whole number ratio, and that ratio will be fixed. For example, suppose the sentence might look a little bit of clumsy. If I give some example, then if you understand, then it automatically, if you can frame your own sentence. For example, suppose we talk of a simple compound, that is water. So water is formed from where? Water is formed from the two elements, hydrogen and oxygen, right? Now, doesn't matter how the water is produced, where the water is produced, who produced the water, who prepared the water. Okay, it will be always having hydrogen and oxygen, and it will always having the ratio of number of hydrogen and oxygen as 2:1, and hence the mass of hydrogen and oxygen will be 2:16, as the atomic mass of hydrogen is 1. So 2 atoms of hydrogen means 2, and atomic mass of oxygen is 16. So 2:16 doesn't matter where we had produced it, how we had produced it. Is it clear? That is law of definite proportion. So what does it say? It says that a compound that is produced from different elements will be in a fixed or definite proportion, irrespective of from where and how that is prepared. Is it clear? Okay, so let's just solve a problem, then it will be easier for, or understanding will be easier for you. So let's do it. 1.375 gram of CuO. So let me write down the question here so that you can copy it and then we can do it. 1.375 gram, 1.375 gram of CuO is reduced by a current of hydrogen, and the weight of copper, and the weight of copper that remained was 1.098 gram. 1.098 gram. In another experiment, in another experiment, 1.179 gram, 1.179 gram of copper was dissolved in HNO3, was dissolved in HNO3 and the resulting copper nitrate and the resulting copper nitrate CuNO3 whole 2 resulting copper nitrate converted into CuO converted into CuO by ignition fine. The weight of CuO is 1.476 gram. Show that these data is in agreement with law of constant proportion. So this is the question. Again, the same thing while solving the numericals. I told you that first you read the question nicely, understand it. Then we are going to proceed. What is the 1.375 gram of CuO is reduced by a current of hydrogen and the weight of copper that remained was 1.098 gram. That's the first thing. So which compound is there? Which compound they are talked of? And obviously this question is related to what? This question is related to law of constant proportion. What does this law of constant proportion say? That whenever we form a compound by different methods, the ratio of the elements present in them will be same, right? So first of all, we must understand that what is the compound we are talking of. So here we are talking of, you see, first experiment we are talking of the compound CuO. Now see the second experiment, obviously we must be talking of also CuO again. In another experiment, 1.179 gram of copper dissolved in HNO3 and resulting CuNO3 converted into CuO. So the sentences that is written, how it is produced and all is immaterial to us to solve the problem. Our problem is to see what compound we are talking of. So we are talking of what? We are talking of CuO. So in the first experiment, what is given? That obviously the compound is CuO reduced by a current of hydrogen, doesn't matter, and the weight of copper that remained was 1.098. So in CuO, the amount of copper equal to how much? The amount of copper is equal to 1.098 gram. 1.098 grams. See, the question is very simple. Nothing. You must understand it. That's all. So in CuO, if the amount of copper is 1.098 gram, and how much of CuO we had taken? 1.375 gram. How much? 1.375 gram of CuO we had taken. So what is the amount of oxygen? It is simply 1.375 minus 1.098. So that is equal to 1.375 minus 1.098 gram. That is equal to how much gram? Just let us do it. This is 7, 1, 9 and 1, 10, 10, 7, 7 again. Okay. This is 1 again. 1, that is 2. Okay. 0.277 gram. 0.277 gram or 0.277 gram is the amount of oxygen. Fine. So what is the ratio of Cu is to O? Cu is to O is 1.098 is to 0.277. Fine. That's the ratio of it. Is it fine? Okay. Now in the second experiment, so let us keep it like this, or you can get the value of it. Simply you can get the value of it. 1.098 divided by 0.277. So whatever is the value you are getting, you will get this value. Please do it. Okay, you can get this value. That is the value of Cu is to O. Now in the second experiment, what did they say? That the copper oxide is formed, converted into copper oxide. Okay, how much copper was taken into to form the copper oxide? 1.179 gram. 1.179 gram. So that is amount of copper is equal to 1.179 gram. And how much of copper oxide is formed? Copper oxide formed is 1.476 gram. So amount of CuO is equal to 1.476 gram. So what is the amount of oxygen? Amount of oxygen is equal to how much? 1.476 minus 1.179 gram. Fine. That is equal to how much? So let us do it. 9, this is 7 only. Okay. 7 and 1, 8. 8 means 9. It is 9. Okay. Then 1 and 2, 2 and 4, that is 2.297. Okay, 0.297. That is the amount of oxygen. So what is the ratio of, therefore, Cu is to O from the second experiment is equal to how much? Cu is to O from the second experiment is 1.179 is to 0.297, and you can get the value of this also. And these two values should be same, right? That is definite proportion. So after getting these two values, what we are going to say? We are going to say that since the ratio of copper and oxygen in both the experiments is same, okay, so these results or these data are in agreement with the law of definite or constant proportion. So please complete this question. Okay, complete this numerical. Fine. So law of definite proportion is clear. Now we are going to move to the next law, that is law of multiple proportion. What is law of multiple proportion? Please understand it. Law of multiple proportion. What does it say? That two elements combine to form two or more than two compounds. Okay, keeping the amount of one of the elements fixed. If we keep the amount of one of the elements in those compounds fixed, the ratio of the amount of the other element will be a simple whole number ratio. The ratio will be a simple whole number. So let me just explain it, you will understand it better. Suppose we are taking a simple example, carbon and oxygen. The two elements, carbon and oxygen I have taken. Now carbon and oxygen are combining to produce, there are two compounds they can produce. One is carbon monoxide, one is carbon dioxide. Okay. Now what is the ratio of carbon and oxygen in carbon monoxide? The atomic mass of carbon is 12, we know. So 12, and the atomic mass of oxygen is 16. So that is 12 is to 16. And what is the ratio of carbon dioxide? Carbon and oxygen in carbon dioxide, it's again 12 is to 32. Now what does this law say is that keeping the amount of any one of the element fixed. Here the carbon is 12, here the carbon is 12. So that's already fixed, already set. Okay. If we take the ratio of the other elements in the two compounds or more than two compounds, ratio of the other element means ratio of oxygen in the two compounds is how much? 16 is to 32. 16 is to 32, and that is nothing but a simple whole number ratio. What is that? 1 is to 2. If it is a simple whole number ratio, means it is showing or it is in agreement with the law of multiple proportion. I told you have to keep any one of these elements, carbon and oxygen, fixed. I have taken carbon fixed. Now let us just try to do with taking oxygen fixed in this example only. Okay. So let us see. Obviously, if you take the oxygen fixed, also it should be following the law of multiple proportion. Let us see it. It's 12 is to 16. It's 12 is to 32. So we have to fix oxygen. So, okay, let us fix it by multiplying it by 2. If I multiply this by 2, it will be 24 is to 32. Now 32 here, that is fixed. Okay. So what is the ratio of carbon? The ratio of carbon is 24 is to 12. So that is equal to how much? That is equal to 2 is to 1. Again, it's a simple whole number ratio, and hence it is obeying what? It is obeying the law of multiple proportion. Okay. Now one homework for you first, then we will solve a numerical. One theoretical homework for you, and then we will solve the numericals. Write down the homework first. Show that the oxides of nitrogen, show the or follow the, that you should write, follow the law of multiple proportion. Follow the law of multiple proportion. Okay. So show that the oxides of nitrogen follow the law of multiple proportion. This is your homework. Now we will move to a numerical. So please do that with a multiple proportion. Now we will move to a numerical. So let me write down the numerical first, and then we will do it. Okay. Okay. Fine. Right. Hydrogen and oxygen. Hydrogen H. Okay. Hydrogen. Let me write in words. Hydrogen and oxygen. Hydrogen and oxygen are known to form two compounds. Are known to form two compounds. Full stop. The hydrogen content in one of these is 5.93%. 5.93%. While in the other it is it is 11.9%. 11.9%. Show that these data are in agreement with law of multiple proportion. Again, to solve the numericals, first of all you must know the theory. So what is law of multiple proportion? That two elements combining with each other forming two or more than two compounds, and if we keep the amount of one of the element fixed, the other will bear a simple whole number ratio. Okay, simple. Now here what are the two elements? The two elements are hydrogen and oxygen, and how many compounds they are forming? They are forming, as they told, two compounds. In the first compound, so two elements are there, hydrogen and oxygen. Now in the first compound, what is there? That the hydrogen content in one of these in the first one is 5.93%. So H equal to 5.93. So if H equal to 5.93%, O should be equal to 100 minus 5.93. 100 minus 5.93. That is equal to how much? That is equal to 94.07. Yes, 94.07. So that is oxygen. So what is the ratio of H is to O? So H is to O equal to 5.93 is to 94.07. Yes, that's in the first case. That's in the first case. In the second case, or in second compound, the amount of hydrogen equal to how much? The amount of hydrogen they mentioned is equal to 11.9%. 11.9%. So amount of oxygen should be equal to 100 minus 11.9, that is equal to 88.1%. Yes. So what is the ratio of H is to O? So H is to O is equal to 11.9 is to 88.1. Right? Yes. Okay. Now what I told, that keeping any one of the element fixed, if we take the ratio of the other one. Now how to keep any one of the element fixed? It's very easy to do it. See, what we are going to do, suppose we want to take hydrogen as fixed. So if we want to take hydrogen as fixed, we are going to divide it by 5.93. That means we are going to make it as 1. So that is equal to 5.93 divided by 5.93 is to 94.07 divided by 5.93. Can I do it? So that is equal to 1 is to something. You will get it. You will get something over here. Yes? Okay. Very good. Now this will be almost equal to 16 anyway. So you can do it. Now next one, how can we make the hydrogen amounts fixed over here? Fixed means we have to make it 1. So we have to divide it by how much? We have to divide by 11.9. So that is equal to how much? That is equal to 11.9 divided by 11.9 is to 88.1 divided by 11.9. We can do it. Yes. So that is equal to 1 is to whatever value will come, you can get it. So keeping this amount fixed, if we take the ratio of this and this, that should come in a simple whole number ratio, and if it comes, means it is agreeing with the law of multiple proportion. Okay, so please complete this numerical also. Next we are going to do so many other numericals also, but before that we are going to end with 2 more terms which is already known to you, but we must understand this again, just 2 more terms, so that we can go for the next class very easily, or with more number of more numericals. Okay, so the 2 terms are, the first of all, atomic mass. Very simple. What is atomic mass? Mass of an atom, nothing else. It's nothing but mass of an atom. All of us know what is an atom. Okay, so mass of an atom is obviously very, very small. Now if I ask you what is the mass of this pen, if I ask you what is the mass of this pen, you will say, sir, we have to measure it. Now whenever we are measuring it, we are taking some standard, then only we are measuring it, 5 gram or 6 gram or 10 gram, whatever, you know that what is gram, then only we are measuring it. So unit is there. Same way, the atomic masses of the atoms are measured by considering something as the standard. Okay, initially, at the beginning, it was considered hydrogen as the standard. Hydrogen's mass had been considered, again I am saying considered as 1. What you know, the unit is AMU, atomic mass unit, or we also represent it by U. Okay, that was considered as 1, and accordingly we measured the mass of the other elements. Okay, for example, suppose if I measure the mass of carbon, we had seen that the carbon's atom is 12 times more than the hydrogen atom. So obviously its mass will be 12 AMU. Okay, if we measure the mass of oxygen atom, it will found 16 times. If we measure the nitrogen atom, it will find 14 times. Like that, every atom could have been measured by taking the hydrogen as the standard. But this method was not very appropriate. Why, you know? Because hydrogen could not react and form the compound with so many elements. Next standard that was taken was oxygen. Oxygen's mass was considered, again I am saying considered as 16 AMU. By considering the oxygen's mass as 16 AMU, we measured the mass of the other elements. Okay, but this was also not very suitable, and finally now the standard that is taken is carbon, whose mass is taken as 12 AMU. So suppose now one carbon atom has got 12 AMU. So 1 AMU means 1/12 of a carbon atom. So 1/12 of the mass multiplied or 1/12 of carbon's mass, how many times the element has is the atomic mass of that. So atomic mass of a substance is what? How much heavier the substance is, how much heavier the atom is. 1/12 of a carbon atom. How much heavier the atom is? 1/12 of a carbon atom. Okay, that is atomic mass. Simply that is atomic mass. And what is the unit? The unit is AMU. AMU is nothing but atomic mass unit, which could be also represented by U. Okay, and the last term for today, that is molecular mass. Molecular mass. Now what is molecular mass? Molecule means obviously it must be more than one atoms. Okay, for example, suppose if I say sodium chloride. Okay, sodium chloride molecule is composed of, or is made of, one atom of sodium and one atom of chlorine. So if I ask you what is the molecular mass means mass of the molecule, mass of a molecule. Okay, now if I ask what is the mass of sodium chloride, obviously that will be nothing but the mass of sodium atom plus mass of chlorine atom. So we must know the atomic mass of sodium, we must know the atomic mass of chlorine, and if I just add it, we are going to get the molecular mass. So what is the atomic mass of sodium? Atomic mass of sodium is 23. You don't have to remember all these things. Just the basic few ones you have to remember, otherwise you don't have to remember. And atomic mass of chlorine is 35.5. So 35.5. Obviously, what are the units? The units are AMU. So what is the molecular mass of sodium? The molecular mass of sodium chloride is 23 plus 35.5 AMU. That is 58.5 AMU. Okay, 58.5 AMU. If I ask you what is the atomic molecular mass of glucose, C6H12O6. C6H12O6. What is the molecular mass of glucose? So how can we find it out? We can find it out very easily. What is the atomic mass of carbon? 12. How many of them are there? 6. So 12 into 6. What is the atomic mass of hydrogen? 1. Into how many of them are there? 12. Plus what is the atomic mass of oxygen? 16. How many of them are there? 6. This much what? This much AMU. So equal to how much? 6 12 is 76 plus 12 plus 16 6 is 96, right? Okay. So that is equal to how much? 76 and 12 is 88. 88 and so that is how much it is coming? 6 to 8 and 6. 8 and 6 is 14. 4. Okay. Okay, so 17, 12 6 how much? Sorry, I did a mistake. 12 6 72. Okay, plus 12 plus 96. So 6 plus 2, that is 8. 8 and 2, 10. Okay, then 9 and 10, 11. 11 and 7 is 18. So 180 AMU. 180 AMU. Okay, so 180 AMU is the molecular mass of what? 180 AMU is the molecular mass of glucose. So you can find out the molecular mass of any compounds. You can find if you know the atomic masses of them, and obviously once again I am saying that you don't have to remember the atomic masses, you must have the concept clear. So let us finish it up over here only today. We are going to follow this up with a lot of numericals, with the other laws. Other laws means with the laws which we had already studied, and we will proceed further. Thank you so much.